Now, let's discuss how LangChain integrates with USearch. This integration allows LangChain to use USearch's capabilities for storing and searching vector embeddings. Let's dive into semantic search. Semantic search means finding results based on the meaning of the query and documents, rather than just matching keywords. This is achieved by comparing the vector embeddings of the query and the documents. For example, a search for big cats might return documents about lions and tigers, even if those words aren't explicitly used in the query. Here, option A states that USearch offers a high-performance, disk-based approximate nearest neighbor, AN, index, ideal for extensive datasets exceeding memory capacity. An AN index allows for fast approximate searches in high-dimensional spaces, trading some accuracy for speed. For instance, consider searching millions of document embeddings. USearch's disk-based AN index efficiently handles this without requiring all data to reside in memory. Oh, that's a great point. It's like having a super-fast librarian who can find the most relevant documents based on what they mean *, not just by keywords. Think of it as upgrading from a keyword search to a mind-reading search engine for your documents. The USearch class acts as a user-friendly interface. It hides away all the complicated stuff involved in directly talking to USearch allowing developers to easily add information, remove it, and search through it. It's like having a remote control for the USearch database. USearch is like a highly optimized database, specifically designed to find similar vectors super quickly. The AND part means it doesn't always find the absolute closest match, but it's very, very close and * much faster, especially when dealing with massive amounts of data that would overwhelm your computer's memory. It smartly uses disk space to handle these large datasets. This statement isn't quite right. USearch is actually pretty flexible. It supports more than just cosine similarity. Distance metrics like Euclidean distance and dot product can also be used. The ability to choose different distance metrics is super important. Different metrics work better depending on your data. The question is asking you to identify which statements correctly describe how langchain_community and USearch work together for storing vectors and finding similar ones. It's testing your understanding of their capabilities and limitations. Choose all the options that apply. Now, let's look at the problem statement itself. It sets the stage for evaluating 4 statements related to the integration of langchain_community with USearch . Let's consider statement A. This highlights USearch's ability to handle large datasets efficiently. The key here is the disk-based aspect, making it feasible for datasets exceeding available memory. The statement also accurately points out that USearch uses an approximate nearest neighbor index. ANN indexes trade off some accuracy for increased speed, which is very important for large datasets. Here's statement B. The core idea is that langchain_community acts as a bridge to use USearch within a LangChain workflow. By enabling semantic search over document embeddings using LangChain, we are able to identify documents whose meaning is close to the search query, even if the exact words don't match. Statement C contains an inaccuracy. USearch supports multiple distance metrics, not just cosine similarity. The ability to use different metrics like Euclidean distance or dot product is important because the optimal metric depends on the specific embeddings and the nature of the data. Being flexible is key. Now, let's look at statement D. The USearch class in langchain_community provides high-level methods for adding, deleting, and searching vectors. This abstraction simplifies the process of interacting with the underlying USearch index directly. These methods provide a simpler, more manageable way to perform common vector database operations. Finally, the answer to the problem statement is A, B, and D.